Hey, we're going to try and find the derivative using a chain rule. The function we have is the cosine of 6x squared minus 4x plus 5. We know how to take the derivative of cosine, but in this case we've got something more complicated than a single variable inside the cosine. We've got 6x squared minus 4x plus 5. So we're going to use the chain rule and let that be our u. So we know derivative of cosine is negative sine. And we'll put our u back in there, and then we have to tack on the derivative of that u. So, first of all, inside the function, we'll rewrite our 6x squared minus 4x plus 5, and then tack on the derivative of that, which will be 12x minus 4. Okay, and I don't know how much of that you'd want to clean up, but that was pretty simple. Okay. Our next example is the natural log of the tangent of x. And we know how to take the derivative of natural log of a single variable. So we'll let the u in this case be the tangent. This is our g, this is our u. So following that up, the derivative of natural log is 1 over x, so the u will go in there. And then we will tack on the derivative of u. So we'll put our tangent back in here in the denominator, and then it'll be times derivative of tangent, which is secant squared. So I don't know if that cleans up much at all. It probably does considering trig functions, but I'll just write as secant squared over tangent of x. I'm sure there's something we could do with that to make it look a little bit better. I'll let you play with it if you want. But identifying the correct u and figuring out what it is. So the natural log is the f, the tangent is the g or the u in this case. The last version here we're doing is the sine cubed of 9 minus 4x. So be very careful there. Some people don't always catch the notation here. So let's see here. I've got a little bit more going on here than usual. So this is the sine of 9 minus 4x, and then that guy, let's use some extra colors here, is cubed. So I think we've got a chain rule inside of a chain rule. So the first time we do the chain rule, or the first version, is we're looking at a cubed function. So what's being cubed, or what our u is this sine of 9 minus 4x. So derivative will look like, we'll pull the 3 out front, the original u will go back in, and then we will tack on the derivative of u. So our original u here is, this will be squared, 3 times something squared. That something is the sine of 9 minus 4x. So we need the derivative of that u on the outside. Well, the problem is that's another chain rule. So I don't have to rewrite it separately, but just to make sure you see it, sine of 9 minus 4x. In this case, there's a different u. So that derivative, if we look at derivative of the sine is cosine, and that u was 9 minus 4x, and the derivative of that is negative 4. So in this case, here's the u, and here's a u prime. But the thing that we're looking for to go in our function is this whole thing. And we'll rewrite it as negative 4, messy, cosine of 9 minus 4x. Let's use a little extra color to make sure that nothing gets blended together that shouldn't. Now we could definitely clean that up a little bit, because 3 times negative 4 would give me negative 12. Maybe it'll look a little bit better, maybe it won't. But the final answer, 3 times sine squared of 9 minus 4x, and then all that's times negative 4 times the cosine of 9 minus 4x. So there's our final answer. Anytime you have a chain rule inside of a chain rule, it seems to get a little bit messy. Okay. Thank you.